Okay, we're moving right along with the Institute review of Unit 4 on electric circuits. Now we're dealing with number 7 and 8 of our multiple choice questions. These are dealing with the concept of resistivity. So our equation is that resistance is equal to the resistivity times the length of the material over the cross-sectional area. So in number 7, it says the resistance of a certain substance is 100 ohms. So that's pretty new. What is the new resistance if the length is doubled and the cross-sectional area is halved? So looking at this equation, we're going to increase this by a factor of 2. That would increase my resistance by a factor of 2. Then we're going to decrease this by a factor of 2. That's what cutting the area in half means, that we're decreasing it, or you could say increasing by a factor of 1/2, either way. But this is an inverse relationship, so that would cause an increase in my resistance by a factor of 2. 2 times 2 is 4, so my resistance should increase by a factor of 4. 4 times 100 is 400. Ding, ding, ding. Letter A. Then down here on this one, we talk about them all being the same material. So that means their resistivity is all the same. They have different lengths, different cross-sectional areas. Which wire has the greatest resistance? So looking at this equation, what we want is pretty much exactly what would just happen with number 7. So we want the length to be as large as possible, and we want the area to be as small as possible. So the largest length looks like the 2L. So it looks like D and E are in the running there. And then the smallest area looks like letter E is a little bit better because it's the smaller area. So we would want it to just be 2. So I like letter E. Letter E. And we're good. That's a little bit on resistivity.